Download this code from codegive.com, link in the description below. Certainly. Let's dive into the concepts of horizontal and vertical scaling, their definitions, advantages, disadvantages, and provide some code examples to illustrate how you might implement each type of scaling in a real-world scenario. Understanding scaling. Scaling is the process of increasing the capacity of a system to handle more load. There are two main approaches to scaling. 1. Vertical scaling, scaling up. This involves adding more power, CPU, RAM, to an existing machine. It's akin to replacing a smaller car with a larger one. Advantages. Simplicity, easier to implement, as you are just enhancing a single machine. Less complexity in application architecture. Disadvantages. Limited by the capacity of a single machine. Can be cost prohibitive. There may be a downtime when upgrading. 2. Horizontal scaling, scaling out. This involves adding more machines to your pool of resources. It's like adding more cars to a fleet. Advantages. More cost-effective for large-scale applications. Can handle more load by distributing it across multiple machines. Provides redundancy and fault tolerance. Disadvantages. More complex to implement due to the need for load balancing and data distribution. Requires changes in application architecture to handle distributed systems. Code examples. We'll use a simple web application scenario to illustrate both types of scaling. For our examples, we'll consider a web server written in Python using Flask, and we'll simulate scaling by using a basic in-memory data store. Vertical scaling example. In a vertically scaled application, you might just upgrade your Flask app to handle more requests by increasing its resources. In a real-world scenario, you might increase the number of threads or processes if you're running Flask in production with a WSGI server like Gunicorn. Horizontal scaling example. In a horizontally scaled application, you'd set up multiple instances of your web server and use a load balancer to distribute the incoming requests. Here's a basic example using Flask and simulating multiple instances. 1. Create a simple Flask app, app.py. 2. Run multiple instances of the Flask app, simulating horizontal scaling. 3. Set up a load balancer, could be Nginx, HA proxy, etc., to distribute the requests to these instances. Here's a basic example of a Nginx configuration. Summary. Vertical scaling is simpler but has limits. It works well for smaller applications or during the initial phases of development. Horizontal scaling offers better performance for larger applications but requires a more complex architecture, including load balancing and distributed data management. Choosing between vertical and horizontal scaling depends on your application's needs, traffic patterns, and growth expectations. For most modern applications, horizontal scaling is preferred due to its flexibility and resilience.